Okay, once we have our vesicles segmented, we're going to annotate them manually using the membrane annotation tool provided by TomoSegmentTv. So let's go back to our project and search with Ctrl F to the annotation protocol. Double click here, and it is a very simple protocol. I only have to introduce the pointer to the segmentations obtained before. So let's execute it, and then this window appears, and each element of this list is corresponds to one of the elements of the introduced set of Tomo mask or segmentations, and the status is used just to indicate if the annotation have been done before or not. So you can interrupt this task having not all of them annotated and go back to the point where you left at any time. So let me annotate the first one, double click on this element, and now we are calling the membrane annotator tool provided by TomoSegmentTv plugin, which has been written in MATLAB. Let me do a quick overview of all the elements by the time we're using it. I'm going to start from the top to the bottom. Okay, so this slider is used to manipulate the value of the threshold just for removing these undesired structures that have been detected during the segmentation. Because this data is synthetic data, it's very easy to find one threshold in which the view is clean. But for real data, you have to play a little bit with these and also with the slice, because sometimes with the real data, its circumference seems to be incomplete, like with some discontinuities, and in the end is a visual effect of the view. So you can move from one slide to another, and maybe you can find one in which everything is completed, and that way it means that you are working fine. So these values can also be manually introduced by just typing the number and pushing the enter button, and that would move us to the corresponding set slice. Here you can observe the full path of the file you are loading. This view panel is used to move from the original view, the threshold view, and the other ones that are going to be shown later. So the next section is the crop panel. It can be used to avoid border effects if they are affecting to the labeling or the structures you are trying to filter with the threshold and so on. So you can introduce the numbers in the x-axis, y or z, and update will make a cut depending on the values you have introduced here. Then another thing is the size threshold panel. Let me click on update labels. With this operation, we're assigning it a value which corresponds to the number of voxels it contains. So here we can click on the cursor, and it would tell us that this structure contains more than 96,000 voxels. Okay, so now I can stop this cursor. Another thing that I can do if I have very dirty representation with a lot of undesired structures is once I know the size of this one, or by clicking on them in the label view, the size of it, you can introduce the size of the objects you want to be displayed, and the rest of them will be removed. For example, if I would like to remove all the objects, for example, imagine I have here structures that contains 20,000 voxels. I would just do this and size threshold. This would filter all the small undesired structures. So now, once I am in the desired scenario, what I have to do is just move to the next panel and click on display cursor. Then I should click here and add a material label. I recommend to use this kind of tools just to make a quicker and easier click, because sometimes we have a lot of structures here which can be a little bit difficult to annotate, so in case the lines are very thin. So once I'm observing the membrane I want to annotate, I just click here, and what I'm going to do by this operation is to update this number, which is the one which has been automatically assigned to this membrane, to, in this case, 1. So I click on change label and it takes us to the material view. So in label view I have all the structures are automatically annotated with the number of voxels they contain. But with in the material view, what I see is the annotation that I have performed manually, which is, in this case, all the background will be 0 and this membrane would be labeled with value 1. I would do the same for other ones. For example, if I would have a smaller one here or here, I can annotate them with another label and so on. Save labels button here in the result panel will save the data considering this automatic annotation with the size, and the materials will save the info contained in this panel, which means the manual annotation. Scipion is expecting this one to be saved to continue working and mark this one here as done. You can also save labels for any other purpose, but Scipion won't consider it has been done until you save materials. And finally, we have here this list just as a small log, which is telling you what are you doing, which actions have you been carrying out during this execution. So let me save it. Materials were currently saved, so now I can close it. Now this window should be refreshed, as you can see, and now I have this one done. Let me now annotate the other ones very quick, and I will move to the last one. Okay, so this is the last one. Let me quickly annotate it. Labels, display cursor, annotate it, change label, and save material. Now I can close it, and finally all of them will be done. I can close this, and if I refresh here, what I see is that my objects have been annotated. So it is a set of annotated tomograms, in this case with one membrane each, annotated with label 1. And we can observe them with, as before, with the data viewer, iMode viewer, but we have also offered a 3D viewer which can be displayed by clicking in Analyze Results. Let me execute it. Now this is the results I have obtained here, the Tomo masks annotated, and let me double click on one of them, and it will launch the 3D viewer. Here you can represent the tomogram, as you can see, and the vesicle. So it provides a very nice view. In case you have more than ones, each of them will be painted in a different color representing its index. You can rotate it, you can move the slice, you can cut and change the plane, and so on. So I think it's a very useful tool to offer a better visualization of the data. And that's all for the annotation. Now at this point we are ready to move to PySeg.